Hello, everybody, and welcome to track B for the 12 o'clock talk. First of all, I would like to thank our gold sponsors for today's conference, which are Amdocs and Checkmarks. You can learn more about them on the conference website, the EPSIC-IL. Today, or now, we have a talk by Alexander, who is joining us from Moscow. The topic of the talk is Architect of Threat Landscape, how to secure your microservice-based system. So, and I will allow Alexander to introduce himself a bit more at the first slides of the talk. Regarding questions and answers, questions that you have, so there's the Q&A button at the bottom of the Zoom screen. You can put in your questions over there, and we will take a look at them and try to answer them at the end of Alexander's talk. So without further ado, Alexander, the stage is yours.
Thank you very much. Hello. Thank you for joining this meeting. Let me share my screen. So can you see my screen now?
Yes, we can.
Yeah, I think. Okay, thank you very much. So imagine that you're an application security engineer that was recently hired by a small young company or startup without any mature development processes. And the application that company developed is a microservice-based application, and you are the only one person responsible for application security. And you probably used a framework like OWASP SAMM in order to establish some application security processes. You provided self-assessment, created a roadmap, and even started to implement some application security activities like security testing or static code analysis. At one day, you understand that you have to implement some activities from design portion like threat assessment or security architecture. But in order to do that, you need some input information about architecture or the application you want to secure. You would like to have something from high-level design or low-level or some diagrams. But if your company is a young firm without any mature development processes, there are probably no such artifacts at all, or several artifacts are in place, but they are not suitable for such application security activities. So you as a single application security engineer have to create some approach on how to collect security specific information in order to implement some application security activities. And the goal of my presentation is to offer some proposal of approach to collect microservice-based architecture information and use that kind of information to secure your application. My name is Alexander. I'm from Russia. Currently, I'm working for Advanced Software Technology Lab at Huawei. I have an experience in securing microservice-based systems and application security evaluation. In my spare time, when I'm not with my family, I try to deliver a lecture on application security at Bauman Moscow State Technical University, and also try to contribute to OWASP, especially to OWASP cheat sheet series. So why do we need to document secure architecture? So roughly speaking, it may help us to answer a huge amount of questions related to security, like what scopes or API keys does microservice minimally need to access other microservices API? What grants does microservices minimally need to access the database or messages queue? What storages or messages queue do contain sensitive data and other? But dealing with a young company, all we usually have is just repositories with a source code and maybe some PowerPoint presentation with a high-level design. And on the other hand, microservice-based systems tends to change their architecture approximately every sprint. So every sprint you probably face with a new microservices or a new functionality or a new storage or a new connection between microservices. And thereby to have an up-to-date security documentation for microservice system is a very challengeable task, because you need somehow to collect that information, you need somehow to update it probably every sprint, and that operation should not take too much time. And more importantly, you have to use that collected information on a daily basis to make your application secure. And next slide propose what architecture-specific information can be collected in order to implement some application security activities related with the design portion of OWASP SAMM. And again, I should mention that proposed approach is a just starting point and applicable when you don't have any established documentation processes. So firstly, you should identify and describe your application functionality services. That are the services that implement some business-related function like storing customer data or displaying some product catalog. And you should collect some information. For example, you should collect unique service name or ID, very short description of business process or functionality implemented by microservice, and I think 1 or 2 sentences are enough. Link to source code repository, information on development team which own or develop the microservice, because it is usual to have several development team are working on the same product, but you have to know the team and ask questions for some special team if you have any question about that particular microservice. If microservice expose some external interfaces and that interfaces have some kind of specification like Swagger specification or Open API specification, you should also put it on the table. And you may also collect some additional information like link to runbook or some internal structure or low-level design. It is not necessary, but it may help you. And I should mention that you should not collect too much information. For example, information about third-party components or libraries used in microservices can be easily extracted from source code repository via analyzing POM file similar. And to collect that information, you should you can investigate project repository, investigate testing environment, collaborate with a system architect or lead developer. The second stage is to identify and describe infrastructure services, because you probably use some infrastructure services that is a general purpose services, including some remote services that does not implement any business related functionality, but some kind of general purpose functionality like service registration and discoveries, API gateways, OAuth to authorization service or logging, and also as well as for functional, for business function services, you should collect some information like ID, like a short description, like, for example, OAuth authorization service, JSON Web Token generation, link to source code repository. And if you have, you should also put a link to the service documentation on the table. The next type of building blocks you have to understand for your microservices system and collect information is data storages. It could be database management system, it could be cache. And again, you should collect information related to each storage, like a storage name, for example, like Postgres #1 or Cassandra #2, and software type like Redis, Apache Cassandra, Postgres. And to collect this information, you can investigate project repository or configuration in YAML file. or you can collaborate with your system architect or your development team lead in order to derive that information. Because event-driven architecture is widely adopted pattern, there probably should be a messaging system in your architecture like Apache Kafka or RabbitMQ, and you have to also identify those message queues systems, and also collect some minimal numbers of information like identifier and software type. And to do that, you again could analyze your testing environment, or analyze some repository, or analyze configuration in YAML files, and collaborate with your team member like system architect or development team lead in order to get that information. And the final step dealing with collecting information on the building blocks is to identify data assets. So that step is more intelligent than other, because you cannot just inspect repository or execute one command and list all necessary information. And to identify data asset, you should actively collaborate with other members of your team, which understand the business purpose of your application. It could be guys like product owner or business architect. And obviously you could not identify all information at once. So it is advisable firstly to identify assets which are valuable from a security perspective. For example, if you have some user information or payment information or some confidential information, you should identify it and again put it on some table with a unique ID, unique asset name or unique asset ID. If you know, you should also put a protection level, for example, personal information or confidential information. And you may add some additional information that clarify that type of data assets. And again, you cannot just execute one command. You have to collaborate with a business architect or product owner in order to understand the main business function of your application, main feature and data, in order to derive what data assets and are valuable from security perspective. After you identify and describe building blocks like functional services, general purpose services, data storages, message queue, and the data assets, you have to collect information on relations between those building blocks. And the typical relations are service to storage, service to service, storage to asset, and so on. So during service to storage relation identification, you should identify direct connection between service and storage. So for example, on that slide, microservice called user details have a connection via JDBC protocol with Postgres, and you have to identify those connection. And to identify that connection, you may analyze some testing environment, or ask your team lead or development team lead or system architect, or even analyze YAML file in order to understand which microservices have an access to which storages. And also, as well as some connection between service and storage, like service ID and storage ID, you also have to identify an access type. For example, read-write access type, or only read access type, and that will help you in the future activities related to application security. The next type of connection is the asset to storage connection. So you have some types of assets like user details information or user payment information, and you have to understand which storage does contain that asset. And again, you you collect some information about asset ID and corresponding storage ID, as well as a storage type, because storage can be a golden source for that asset, or it may be a cache. Because, for example, in that slide, we can, on this slide, in the next slide, we can take user data from Postgres and store it into some additional storage like Redis. And for that type of storage, it will be cache, not golden source. So you have to identify, is it a golden source or is it a cache with particular storage type. The next portion of connection is about connection between service to service, because services can synchronously interact with each other using protocol like HTTP or gRPC. So you also have to identify those interactions and describe it using parameters like caller service name, called service name, protocol or framework used to communication, and short description of the purpose of that communication. And if possible, you should use data assets identified above to describe that interaction. For example, if connection between microservice user details and service UA that implements some authorization is only for get some user attributes, you should put it on the table, because you should use data asset ID in order to explain, in order to clarify that communication. And again, the main source of that kind of information could be some development in environment, some configuration file like YAML file, and other members of your team like system architect or development team lead, and so on. Services can also interact with each other asynchronously via messages queue. For example, on that slide, message number, microservice number, just a moment, please. In that slide, microservice number 2 and microservice user details interact with each other using Kafka message queue. For example, microservice number 2 could be a publisher, and microservice name, the user details could be subscriber. But anyway, this is a connection between services, and you have to identify those connections in order to secure your application more precisely. And to identify and to describe those type of communication, you can use parameters like publisher service name, subscriber service name, message queue ID identified above, and a short description of the purpose of that communication. And again, if possible, you should use data assets ID identified above in order to describe the purpose of communication. For example, if during that communication between microservice 2 and microservice name user details, we publish some user data to their topic, you should identify it and put that information on the table. So you may store collected information using very basic tools like a simple spreadsheet or Confluence page. In the future, you can even create some kind of digital twin of your microservice system that is maybe some special application that automatically collect all necessary information from, for example, testing environment or YAML files, and store it information and help you to automate your application security activities. But just for starting point, you can use very simple, very basic tool like a spreadsheet or Confluence page. It is also advisable to create a graphical presentation of application architecture, building blocks and relation defined above. And in order to do that, you can use a special software, for example, Enterprise Architect. You may use a Paint, you may use a PowerPoint, but it is more advisable to follow architecture as a code approach and to use some language in order to describe your architecture. So you can simply use language called DOT, graph description language, simply define some building blocks, simply define some connection between that building blocks, simply add some valuables label, like type of protocol or type of data asset that path between microservices. And to be more useful, you should avoid to represent all data flows, but only data flows with the identified assets. So for example, we all understand that you have an HTTP request and HTTP response, but if data asset is only in HTTP response, you should put on your configuration only HTTP response and say, hey, the asset ID in that response. So again, it is more useful to use architecture as a code approach and create some graphical presentation of application architecture using some languages. And I should mention that languages also can visualize your application architecture and to get some beautiful image. And the next step, and the main step, is that you have to use that collecting information for doing application security practices. For example, during security requirements definition or threat modeling or security testing. And let's consider some use cases based on OWASP ISOS requirements, and talk about how can we use that collected information in order to implement some application security activities. So the first requirement is about use of threat modeling for every stage or for every change in architecture or for every sprint planning. And so during sprint planning, you can easily modify your architecture diagram, add some connection between, you can easily modify your architecture diagram or its part based on proposed architectural changes. You may add some connection, you may add some new microservices, or you may add some information about assets, relation between assets and storage. And then you have that update diagram and description of services and data assets. You can make some threat modeling activities based on Stride methodology or similar. For example, you can ask and answer the following question in order to identify threats and in order to identify some mitigation strategies. For example, do we really need connection between front-end application and UA, which is a authorization service? Does microservice number one really need an access to user details microservices and an access to user data? Where does sensitive information store? Are there any information leakage via microservice one and Redis possible? So, and then answering those questions, you can create some mitigation technique to create some non-functional requirement in order to secure your application. Next requirements from OWASP ISOS is enforcing the principle of least privileges. And let's consider how can we use our collected information in order to implement that security activity. So again, having diagram and having description of microservices, of general purpose services, of business functional services, we can easily ask and answer some questions. For example, does user detail microservice really need a read-write access to database management system named Postgres number one, or microservice user detail just need only read access? Does microservice number two really need an access to user details? Or you can even use that information in order to do some security testing activities. For example, you can check, does actual configuration file with the database account is equal to required permission in the table. So you can, during security testing activities, you just verify that account that used by user details microservices has only read and write access, or only read access to database. The other example is sensitive data identification. And according to OWASP requirement, all sensitive data has to be identified and classified into protection level. And again, having that information about relation between storage and assets, you can easily ask and answer some very interesting question. For example, where does sensitive information located, and understand that your main sensitive information, the main data assets are located are stored on Redis and Postgres. Does microservice read or write data from some particular storage? And what microservices are invoked by dedicated microservices? Is sensitive data passed between microservices? And when you answer those questions, you can easily understand where does your sensitive data live, and understand how you have to protect those information. And here is just a quick summary of what type of collected information are suitable for doing some application security activities based on OWASP SAMM. For example, to analyze the principle of least privileges, you may need information about service to storage relation, information about service to service, synchronous and asynchronous communication, and so on. Our other example of requirements from OWASP that could be met by using collected data is on the slide. For example, to verify definition and security analysis of application high-level architecture, you may inspect and you may review information collected under blocks, application services, infrastructure services, data storages, and message queue. And that list is not exhaustive, and I think that there are other requirements from OWASP that could be met by using collected information on security architecture. So again, thank you for joining my presentation, and here are some key points. So even if you don't have any established process dealing with young company or startup, when you don't have a documentation, when all you have is just a source code repository, some high-level design in PowerPoint presentation, you should start to document your security architecture, because it will help you to find more interesting and more sophisticated architectural vulnerabilities. Because on the one hand, you may use a static code analysis and security testing in order to find some bugs, but in order to find some very interesting vulnerabilities related with your architecture, you need to understand your architecture. And again, you should start to document, to somehow document your security architecture. The next point here is that you should document only necessary types of information that may help you in your application security activities. So it will reduce time for collecting that information, for updating that information. The next main point here is, do not just collect information, you have to use it at a daily basis during sprint planning or other activities, and keep it up to date, because the main target of you as an application security engineer is not to collect architectural information, but implement mitigation in your application code base. The next point is that it is recommended to use some kind of software architecture as a code approach. So instead of doing your high-level design in Paint or PowerPoint, you should use some language to describe your architecture and describe your connection, because it is more convenient, and allow you to even use some version control systems. And last but not least point is do not bury your head in the sand, because you have to actively collaborate with other team member. You have to collaborate with the developers, system architects, with the QA guy, because they will bring you very valuable information, and you could make your software more secure. And here are some reference to existing cheat sheet. So my presentation was about OWASP cheat sheet called microservice security architecture documentation. Feel free to view it. Feel free to mark any issues or even contribute to that cheat sheet. And other cheat sheet is related to microservice security, and that cheat sheet contains information about some typical architectural pattern to implement security function like authorization, authentication, identity propagation. And again, feel free to view that cheat sheet, use it, mark any issues, and collaborate to OWASP and contribute to OWASP community. Again, thank you for your attention. If you have any question, feel free to use Q&A portion of Zoom.
Alexander, thank you very much for the excellent talk. If anybody has any questions, you're more than welcome to use the Q&A at the bottom of the Zoom window. Okay, looks like we don't have any follow-up questions. Alexander, thank you very much.
Thank you very much. Thank you very much. Bye.
Oh, wait. Here, questions are coming in. Do you see the questions as well?
Uh-huh.
All right, so two people asked about threat modeling tools. Yes, the question is if you have recommendations. What tools do you recommend to use?
Okay, so roughly speaking, from my point of view, it is more convenient to create some kind of checklist, because if you will try to adopt tool like Microsoft's Try tool or something other, you may miss some very specific information related to your system. So from my point of view, it is more convenient to have some checklist and to think about the question from checklist in every sprint planning. It was interesting checklist from company called Autodesk. I think it's a very good starting point. The next question is, what is recommended language to record architecture? I personally use GraphViz and .language. It is convenient to just record your architecture, to document your architecture, and to create some changes in your architecture. I have been, this is an answer, Microsoft and also Dragon.
Right, it's the same person who asked about the threat modeling tools. So she's saying that she used the Microsoft for threat modeling and the Threat Dragon by OWASP tools. Yeah. Another question here, which method for threat modeling do you recommend? Stride or something else?
I think as a starting point, you have to derive some some thread specific to your application system from Stride methodology. You can also consider Mitre attack matrix that contain some information about some tactic and technique related to attacker. But again, I don't think that there is some general purpose list of all threads, because every application system is unique. Every application system has their own unique business feature. And so my point is that you have to start with some basic threads, like stride or like Mitra attack matrix, and then derive some specific threads. Based on that threads, create some checklist and use it, for example, every sprint. Autodesk cheat sheet, yeah, yes, it was. It is not cheat sheet. It is a...
Sorry, go ahead.
Yes, I will share. It was a question about cheat sheet I mentioned above from a company called Autodesk. Yes, I will share a link, and it seems that it called something like automatically thread model. Yeah, I will share a link.
Okay. I'll just say about the stride or something else. So usually in the thread modeling book by Shostak, he also says that it doesn't matter really what you use as long as it's something that works for you. So taking also what Alexander just said, it's true that you need to be able to use something that works for your microservice and your setup and platform, and not one specific sort of thing. Any recommendations for thread modeling as code?
I think I don't have any special recommendation. I know that OWASP community has a tool that can help you to make thread modeling as a code, but I never use that tool. I just use some simple checklist in order to derive some threads and some mitigations.
Okay, any more questions? If anybody has any more questions.
How can I share a link? Type answer. Okay. I have shared a link on some resource called from Autodesk called Continuous Thread Modeling.
Right, it's on GitHub under Autodesk, Continuous Thread Modeling. Everyone can see the answered question. The question was, can you share a link? And the answer is the link to Autodesk Continuous Thread Modeling. Excellent, Alexander. Thank you very much for joining us. Thank you for the excellent talk.
Thank you very much for joining. Thank you. Thank you. Bye.
Bye-bye. The next talk on this track is going to start at 1 p.m. Israel time, which is in 20 minutes. Until then, go grab something to drink, something to eat. See you guys later.